If you want to know what's behind a wall, you simply walk into the room on the other side and look. That's a simple idea. But what if the wall is the universe itself? What if reality has an edge that cannot be crossed? Not because we lack technology, but because space and time themselves refuse to let us pass. This question has haunted humanity for thousands of years. At first, we believed everything existed on Earth. Then we discovered the sky, the stars, the planets, and eventually entire galaxies. Each time our understanding expanded, the boundary of reality moved farther away. Today, we face the largest boundary of all, the edge of the universe itself. But before we ask what lies beyond it, we need to understand what we actually mean by the universe. Modern cosmology makes a crucial distinction between the observable universe and the entire universe. The observable universe is not defined by a physical wall or barrier, but by time. The universe is about 13.8 billion years old, and light can only travel so fast. This means we can only see objects whose light has had enough time to reach us since the beginning of cosmic history. Everything beyond that distance is invisible to us, not because it doesn't exist, but because its light will never reach Earth. And this creates a cosmic horizon, a spherical boundary around us in every direction. Beyond that horizon, galaxies are still out there, but the expansion of space itself pulls them away faster than light can cross the distance. This doesn't violate physics, because it's not objects moving through space faster than light, but space itself expanding. If we could somehow travel faster than light, crossing this boundary wouldn't reveal an empty void or a wall. We would simply encounter more galaxies, more stars, more cosmic structures, forever hidden from our view. But this only shifts the question further. If the observable universe has an edge defined by light and time, does the universe itself have an edge? And if it does, what lies beyond it? This is where science begins to blur into philosophy, and where certainty gives way to hypothesis. No experiment today can tell us what exists beyond the limits of observation. Yet mathematics, cosmic background radiation, and the large-scale structure of space allow us to speculate. Some ideas suggest infinity, others suggest hidden dimensions, and some propose that the very concept of outside may be meaningless. To understand what could exist beyond the universe, we must first accept something deeply unsettling. The universe may not be a place inside something larger. It may be everything that space and time can be. And if that's true, then asking what lies beyond it might be like asking what lies north of the North Pole. Once we accept that the observable universe is limited only by time and light, the next question becomes far more unsettling. What if the universe itself has no edge at all? One of the simplest and most disturbing ideas in modern cosmology is that space may be infinite, not vast, not unimaginably large, truly infinite. In this model, the universe extends forever in every direction, with no boundary, no center, and no outer wall. If you could travel endlessly through space, you would never reach an end. You would simply encounter more galaxies, more stars, more cosmic voids, repeating without limit. At first, this sounds almost comforting. No walls, no edges, no final frontier. But the implications are deeply unsettling. In an infinite universe, every possible arrangement of matter that can exist will exist somewhere. Given enough space, the same combinations of atoms must eventually repeat. That means there could be regions of the universe identical to ours, entire galaxies that mirror the Milky Way, planets indistinguishable from Earth, and, statistically speaking, versions of you reading these words right now, making the same choices, asking the same questions. Not metaphorically, literally. This isn't science fiction. It is a mathematical consequence of infinity combined with a finite number of particle arrangements. Many physicists find this idea deeply uncomfortable. Infinity is a dangerous concept in physics because it often signals that our theories are incomplete, yet observational data does not rule it out. Measurements of cosmic background radiation suggest that space is flat on large scales. A flat universe can be infinite, just like a perfectly flat plane extends forever in all directions. But infinite does not mean simple. An infinite universe would not be uniform everywhere. Matter would clump into galaxies and clusters, separated by immense voids, but the overall structure would continue endlessly. The real problem is that an infinite universe is impossible to fully confirm. No experiment can prove infinity because every measurement is limited. We can only say that if the universe has an edge, it lies far beyond what we can observe. And this leads to a strange conclusion. The question, what lies beyond the universe, may already be flawed. If the universe is infinite, there is no beyond. There's only more universe. No boundary to cross, no outside to reach, just endless continuation. And if that is true, then the real mystery is not what exists beyond the universe, but why the universe exists at all. If the idea of an infinite universe already feels overwhelming, the next concept pushes the human mind even further. What if our universe is not everything that exists? What if it is only one bubble among countless others? This is the foundation of the multiverse hypothesis. According to several modern theories in physics, especially those related to cosmic inflation, that the Big Bang may not have been a singular event. Instead, it could be one of many. In this picture, space itself continues to inflate eternally, and within that expanding background, separate universes form like bubbles in boiling water. Each bubble becomes a universe with its own space, time, and physical laws. Our universe would be just one such bubble, expanding from its own Big Bang, isolated from the others by rapidly stretching space. The unsettling part is that these other universes would be fundamentally unreachable. Space between them expands faster than any signal could travel, permanently cutting them off from us. They would exist, but never interact with us directly. Even more disturbing is the possibility that the laws of physics might not be universal. In some bubbles, gravity could be stronger or weaker. In others, atoms might never form or stars might burn out instantly. Some universes could be sterile, dark, and empty. Others might teem with structures far stranger than anything we can imagine. This idea helps explain one of the biggest mysteries in cosmology: why our universe seems so perfectly tuned for life. Instead of assuming a single universe designed with precise constants, the multiverse suggests randomness. If enough universes exist, some will naturally have conditions that allow complexity in observers. We find ourselves in such a universe not because it was chosen, but because only such universes can be observed at all. Critics argue that the multiverse borders on metaphysics because it may never be testable. If other universes cannot be observed, can they truly be considered scientific? Yet the theories that predict the multiverse arise naturally from equations already used to describe inflation and quantum fields. Whether we like it or not, the mathematics keeps pointing in this direction. And once again, the original question changes. If there are many universes, then asking what lies beyond our universe is no longer about empty space. It is about whether reality itself is layered, fragmented, and far larger than anything a single universe could ever contain. At this point, the question begins to collapse under its own weight, because physics offers a deeply unsettling possibility. There may be no such thing as outside the universe. This is not a poetic statement, but a serious consequence of how space and time behave. In modern cosmology, the universe is not an object sitting inside a larger container. Space itself is the universe. Asking what lies beyond it may be like asking what lies north of the North Pole. The question feels natural, but it has no physical meaning. To understand this, imagine living on the surface of a sphere, like an ant walking on a perfectly smooth planet. From the ant's perspective, the surface is two-dimensional and endless. It can walk forever without encountering an edge. Yet the surface is finite. It has no boundary, but it is not infinite. Cosmologists propose that our three-dimensional space could behave in a similar way, except in higher dimensions that we cannot directly visualize. If space is curved in the right way, you could theoretically travel in one direction forever and eventually return to your starting point without ever crossing a border. In such a universe, there is no wall, no edge, no final barrier. The universe does not end, because ending would require something beyond it. Another possibility is that space is flat but still unbounded, stretching endlessly without any external reference frame. In both cases, the idea of stepping outside the universe becomes meaningless. Even time is part of this structure. The Big Bang was not an explosion into empty space, but an expansion of space itself. There was no location where the universe began. It began everywhere at once. If time itself started at the Big Bang, then asking what came before is like asking what happened before time existed. The laws of physics simply stop allowing the question. This is deeply uncomfortable for the human mind, because we evolved to think in terms of containers, edges, and surroundings. But the universe does not care about human intuition. If this model is correct, then the ultimate boundary of reality is not a wall, but a limit of meaning. There is nothing beyond the universe because beyond is not a valid concept. The universe is not contained within something larger. It is the totality of space, time, and physical law. And if that is true, then the most disturbing realization is this. The mystery is not what lies beyond the universe, but why anything exists at all. Even if the universe has no physical edge, there is still a very real boundary that traps us, the cosmic horizon. This is not a wall made of matter, but a limit imposed by time, light, and expansion. The universe is about 13.8 billion years old, which means light has had only a finite amount of time to travel. No matter how powerful our telescopes become, we can only observe regions whose light has had enough time to reach us since the beginning of cosmic history. This creates a bubble around us called the observable universe. Beyond this horizon, galaxies exist, stars burn, and events unfold, but they are forever hidden from us. And the cruel twist is that this horizon is not static. Because space itself is expanding, distant galaxies are being carried away faster and faster. Some of them are already receding at speeds greater than the speed of light relative to us, not because they are moving through space too fast, but because space between us and them is stretching. Their light, emitted today, will never reach Earth. They have slipped permanently beyond our cosmic reach. This means that over time, the observable universe is actually shrinking in terms of what we can ever access or influence. In the far future, distant galaxies will fade away entirely, leaving only our local group visible in an otherwise dark and empty sky. Knowledge itself has an expiration date. There are truths about the universe that are real, happening right now, yet fundamentally unknowable to any observer inside this cosmic bubble. No experiment, no technology, no breakthrough can overcome this limit without violating the structure of space-time itself. This forces a brutal realization. Physics does not promise complete answers. It only promises answers within reach. The universe may be vastly larger than what we can see, or it may loop back on itself, or it may be one bubble among countless others. But for us, trapped inside one causal region, reality is filtered. We do not experience the universe as it is, but as it allows itself to be seen. And beyond the cosmic horizon, reality continues without witnesses, without measurement, without meaning to us. Not because it does not exist, but because existence does not guarantee accessibility. The edge of the universe, then, is not a place in space, but a boundary in knowledge. And no matter how far humanity advances, that boundary may never move. When cosmologists talk about what might exist beyond the observable universe, the discussion inevitably leads to one of the most unsettling ideas ever proposed by science: the multiverse. This is not science fiction in the casual sense, but a family of hypotheses that emerge naturally from modern physics, especially from inflation theory and quantum mechanics. According to cosmic inflation, The universe underwent an unimaginably rapid expansion fractionally after the Big Bang. But inflation may not have happened just once. Some models suggest it is an ongoing process, constantly spawning new regions of space-time. Each region becomes its own universe, separated from others by vast, ever-expanding distances. These universes do not exist far away in the normal sense. They exist beyond our causal reach, disconnected not by distance, but by the structure of space-time itself. In this picture, our universe is just one bubble in a cosmic foam, endlessly forming and drifting apart. Each bubble may have different physical constants, different strengths of gravity, different particle masses, even different numbers of dimensions. In some universes, atoms could never form. In others, stars might burn out in seconds. In most, complexity and life would be impossible. We exist in one of the rare universes where the laws happen to allow galaxies, chemistry, and consciousness. This leads to the anthropic principle, a deeply controversial idea that states we observe the universe the way it is because only such a universe can produce observers. It feels unsatisfying, almost like giving up, but it may be unavoidable if the multiverse is real. The disturbing implication is that there may be no deeper reason why the universe has the laws it does. No final explanation, no ultimate blueprint, just statistical survival among infinite possibilities. And here lies the greatest problem. The multiverse may be fundamentally untestable. Other universes, if they exist, are beyond observation. Their signals cannot reach us. We cannot visit them, measure them, or interact with them in any way. This places the multiverse in a strange territory between physics and metaphysics. It may be the correct explanation for reality, yet remain forever beyond experimental confirmation. Some physicists argue that this makes it unscientific. Others argue that refusing it simply because it is uncomfortable is worse. The multiverse challenges the very definition of what science is allowed to explain. It suggests that the ultimate structure of reality may be far larger, stranger, and more indifferent than we ever imagined. And if it is true, then asking what lies beyond the universe has a terrifying answer: everything, just not for us. If we ask what lies beyond the boundaries of the universe, we eventually have to accept that the question itself may be flawed. The word beyond assumes the existence of space outside of space, and that is already a linguistic trap. The universe does not have to be an object floating inside something larger, like a sphere drifting in a cosmic ocean. It may simply be everything that exists, the totality of space and time. In that case, there is no outside, just as there is no place north of the North Pole. You can travel in any direction forever, yet never leave the surface, because the surface itself defines the entirety of the world. This sounds abstract, but physics repeatedly leads us to conclusions like this. General relativity describes the universe as a four-dimensional space-time that requires no external framework. Space does not expand into anything else. It expands by stretching itself. That distinction is crucial. When we say the universe is expanding, intuition tells us to imagine an explosion into emptiness. But in reality, it is the distances between points within space that increase. There is no moving edge pushing into a void. Every region moves away from every other region, and yet no point is special, no center exists. From this perspective, the boundary of the universe is not a wall or an edge, but a horizon of knowledge. It is the limit of what we can ever observe, measure, or meaningfully describe. Even if the universe is finite, its true size may be so, unimaginably larger than the observable region that reaching any end would be physically impossible. And if it is infinite, then the idea of a boundary collapses entirely. What remains is a more unsettling conclusion. The ultimate frontier may not lie in space itself, but in the limits of human understanding. The universe may not hide its secrets behind distant walls, but behind the fundamental constraints of observation, causality, and cognition. And perhaps that, rather than any cosmic edge, is the deepest boundary we will ever encounter.